So Jim takes a tile at random. He does not replace the tile, he then takes a second tile. So the first part of the question says, calculate probably that both the tiles have a number 1 on them. So in the first pick, there are 2 tiles from 7 that have the number 1 on them. The probability we get a 1 on our first pick is 2 from 7. Now we've got to combine that with getting a 1 on the second pick, but we have to remember that we've already taken 1 tile with a 1 on it out. So that leaves me 1 tile left out of the 6 that you can see at the top of the screen. So we simply multiply a fraction, that will give me 2 over 42, which cancels down to 1 over 21. That's part A. So B says calculate the probability the number on the second tile Jim takes is greater than the number on the first tile he takes. So a number of ways this can be done. If we pick a 1 on the first tile, we could have a 2, and that will satisfy the condition, 2 is bigger than 1. Or we could choose a 1 on the first and have a 3 on the second, because 3 is obviously bigger than 1. If we chose a 2 on the first tile, then we could choose a 3 on the second, and that will satisfy the condition. But if we choose a 3, there's no tile larger than a 3, so there's no more that we can do. So we now have to work out the individual probabilities of these combinations. So getting a 1 on the first is 2 from 7, and we must combine that with getting a 2 on the second, which is 3 from 6. And that comes to 6 over 42. Now to get a 1 on the first is just the same as before, 2 times 7. To get a 3, well there are 2 3's. We've taken a 1, so there's only 6 left, and so that will be 4 out of 42. Finally the 2 and the 3, well you've got 3 out of 7 chance. 3 out of 7 chance of getting a 2 on the first pick times 2 out of 6, getting a 3 on the second pick, and that comes to 6 out of 42. So all of these combinations satisfy the condition, so we need to add them together. So if we do that, we'll get 6 and 4 is 10 and 6 is 16. That gives me 16 out of 42, and I can cancel that down to 8 out of 21. And that's the answer to part B.